Hello, statistics student. This is the second video for preparing your presentation slides. In the last video, we make 5 graphs by summarizing the data that we have collected. 2 bar graphs. The first one is for the video preference of dramas or different videos. And we choose drama to be success, and then we have 18.44. Second bar graph, we summarized also video preference. X2 is 38, N2 is 63, with the success being drama, 0.6032. So after this, then the first things we want to do is use those 2 sets of sample to create a confidence interval for difference in percentage that prefer dramas for the 2 population. So I recorded the summary here. N1 is 18, X1 is 8, P1 hat is 0.444, 38, and then 63. P2 hat is 0.6032, I think, or is it 23 or 32? Scroll back to see. 32. And then success is, in both cases, a drama. Okay, so you're comparing how the 2 population prefer dramas. What is the difference in percentage? So we would put in the calculator. I'm going to open the calculator here. And we're doing confidence interval for difference in proportion. Okay, so clear everything and then do tests. It'll be two prop C interval. You want to find the confidence interval. My X1 was 38, the younger one, and 63. No, my X1 is the older one, was it? Yeah, I think so. Let me go back. Oh no, yeah. Where is it? In the presentation. X1 is the older one, so I should say population 1, older students. Yeah, I need to keep track because otherwise your number would be wrong. Younger students. So 18, 38. Oh no, this is X2 and 2. I should say X1 would be 8. N1 is 18. So just make sure that you didn't. So that would be 8 over 18. And this would be 38 out of 63. My C level would be, I just picked 95%. So here's my answer, negative 0.4181 and 0.1007. 0.4181. Negative 0.4181. 0.1007, is that right? 0.1007 negative 0.4181, that's right. So I recorded here. So this is the confidence interval for the difference in proportion of dramas. Make sure that you record the success, what you are counting. And then you can do, write this interpretation. We are 95% confidence, those things. And then the analysis, since is 0 in the interval? Yes, 0 is in the interval. They are not all positive or negative in the interval, so there is no difference, right? There's no difference between the two, no significant difference between population 1 prefer population a younger and older student preferring drama for video watching. So do the analysis and the summary here. Next would be do a hypothesis test for the quantitative data. Video, for me, the quantitative data is reaching video watching per week. Mean mean hours of watching. Mean video watching hours between I should not say population 1 and 2, between older and younger students. So my claim was, I should talk about my claim, right? Claim older students watch less video than younger students. And then I record all my data that I collected. So mean is 9.0833. Standard deviation is 6.3576. 0.90833. No, not 9.0833. 0.0833. Let's do 4. 333. Oh, that's 4 already. And then, no, this is not N1. This is X1 bar. Cut. Okay, paste it. Control V. Control V. N1 was, I think we have 18 students only. And S1 was, took a long time to copy. This is for the older one. Yeah, 63576. 6.3576. And 2 have 63, I know. So we go to the younger page, 8.1719. 8.1719, that is X bar. That's the average or the mean. And maybe I'll put it 2 line. And X2 bar, 8.719. S2. Oh, my claim is not here. S2 is 9.4393. 9.4393. I think there is a outliers in the second one, so it makes the number larger. So X0 is this, and X1 would be mean 1 is less than mean 2. Results, and then we do the two-SAM t-tests. That test, two-SAM t-test, because well, we don't want to use data, because otherwise we'll have to enter a lot of data in our calculator. Oh well, we have to enter these again. Have to switch back and forth again. I hate doing that. The order 90833. 9.0833. S1 6.3576. 6.3576. And 118. Yes. X bar 2. Oh, X bar 2, I can do it here. 8.1719. 8.1719. S2. 7 S2, 9.4393. 9.4393. 9.4393. And then in 63, so there they have the things recorded. Scroll down. We're doing mu1 is less than mu2. mu1 is older, it's less than. It's a no. Calculate. So T is 0.4764. 0.4764. And p-value was, I think it's quite big. 0.6818. Okay, so we need to make it a little smaller. Make the font a little smaller. I have an idea. Maybe we just make this really small. Oh, how do you do the formatting? Oh, here. Okay, so yeah, I think you can just do the formatting here. So or maybe I'll just do it so it's one line. A lot of formatting to do. Oops, where did I go? Here. So we're 90. No, this is the confidence interval. So to test from the calculator. That's just not enough space to have all those things. So I think you can just see how you can do this. So now our p-value is 0.661x is less than 0.05. There is not sufficient evidence. Maybe just do 2 slides. Yeah. For the alternative hypothesis, so maybe what you can do is do the results here and then do another slice because it's just very crowded here. Or you can move them so you can have more space. So what should we conclude? So there is not sufficient evidence to support. Yeah, I think I'm gonna do it. Add a new slide, duplicate slide. So for the second slide, I would just do the p-value. The first slide, I would just do just do this. You can figure out. We still have the claim there. We still have the population. Oh, so population 1 should be older students. Population 2 is younger student. Yeah, I think that's much better if you have 2 slides. And then we talk about the conclusion. There's not sufficient evidence to support the claim that young that older students watch less hours of videos than younger students. So this is the conclusion. Okay, so that is the hypothesis test. Basically, you use the X bar and an S1, X2 bar, N2, and S2 into 2-SAM t-test, and then calculate the test statistics and p-value and do the conclusion. The third test that we have to do is test for linear correlation. Earlier, we calculate R equal to 0.1816, and we find the critical value from A6 table to be 0.22. So we're going to just complete our hypothesis test. Again, population 2 is younger student. Oh, well, it is this is oh, okay. Okay, so this one has no population. So X is hours, video watching hours, the first one. And Y is unit taking, right? So we are collecting the data from both samples. X0 is no linear correlations. Xh is there is linear correlation. The hypothesis test would be R equal to negative 0.1881. The full data 0.1816. 1816. We don't have p-value, so or maybe we just do CV from the A6 table is 0.22, and the absolute value of negative 0.1816 absolute value is less than 0.22, so conclude there is no linear correlation. That means not sufficient evidence to support the alternative. So there's no correlation, linear correlation between video watching hours and unit taking, number of unit taken. Number of unit taking. Okay, so that's completed. What happened is R has to be big in order to have linear correlation, but 0.1816 absolute wise is less than 0.22, so there's no linear correlation. So that complete our statistical analysis. So for confidence interval, you use basically use the calculator. Did I talk about it? Use calculator to prop Z interval, right? To find the 95% confidence interval. And then for the hypothesis test, we use two-sum t-test to find the test statistics and p-value. Make the conclusion, and then we test correlation using our A6 table, using the R that you compute from Google Sheets. So so we have completed the 3 required statistical analysis with the results and also the final conclusion written down on our slides. Now this may be too crowded, so you need to like work on making it look nicer, because in a lecture, in a slide, you should not have that many information. Reflection would include what? Yeah, let's see if we miss anything. We did step 6 last video. We did 8. Yes. If we look back at our project, we do we did the 3 things, and then the last things we want to do is the reflection analysis, discuss any bias from the data, etc., etc. So those I leave it up to you. The things that you want to talk about is what's going on? There's anything? Believe it. The topics that you want to talk about. What's going on? uh, oh. don't know what's going on here. There's something going on. There's some numbers here. I can't type anything. There's something strange with this slide. I can just delete this slide. And then I can just insert a text box. Yeah, that's better. Make larger. So the area that you should talk about is your sampling method. Is it a random sample? The samples are not random because the students are from my Math 142 classes. So they are not general students. What about the questions? Are there any issues in the data collection part? And datas. I think some students may misunderstood the question, blah, 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 right? So you can talk about that. Also, you can talk about is it difficult to collect data? Difficulty. Encountered. So this you can share what you have difficulty encountering. Area for improvement. Yeah, so you can talk about how you can better improve your sampling method, and also what about the questionnaire? Maybe you can reword your question or ask different question. And last but not least, I think we should talk about the requirement. So if you need more slides, you can do more slides. Difficulty encounter and the requirement. Oh, maybe I'll just do a different slide. Oh my goodness. Oh, what's going on? Just duplicate this slide. So instead of sampling method, we'll say requirement. Statistical tests and procedure requirement. Statistical analysis requirement. So remember we were doing confidence interval for proportion. So do we have our number of success and failure are both greater than 5? And also our total sample size or sample size for both samples are greater than 30? No, I think this greater than 5 are satisfied. But 30, this is not satisfied. So the conclusion may not be valid due to this case. It is only valid when the central limit theorem apply. You can also do a normal quantile plot if you want to, to say that it may be okay. But if you look at the distribution of our histogram, this one had a large sample size, so we don't care. This had quite a small sample size and actually not very normal. So I don't know, so maybe not very valid. Okay. So these are the things that you need to talk about in your slides. So I think this is a good starting point of a slide. You can also fill in the summary. The summary should include what you have find after the analysis. So like what is the sample proportion, what is the mean hour of watching, and then another summary would be if you have sufficient evidence to see there's a difference between them, like summarize them in these 2 slides. But you can work on it yourself, okay? Or you can look at the student presentations sample to see how they write the summary. So that's all for the second part of presentation slides, summarizing the data by doing a statistical analysis, or actually 3 statistical analysis: confidence interval, hypothesis test, and linear correlation. Okay, and we also talk about how to do the reflection. You can also talk about if there's any bias also. So yeah, here, other than that, you can also. Do you think that if there is any bias in the data? For me, my bias would be all the students from only 2 school. Here is an only college. So this does not represent all college students. So talk about any bias in your sample. That's all I have. So you can, I'm going to share this also so you can use it as a sample. But I didn't finish it obviously. So especially slides number 3 and 4, which is the summary. So you need to work on it. For the others, you need to format it up a little bit better. Yeah, because I think I didn't do a good job. So this, I didn't type it back. The confidence interval, this is too crowded. So you might want to think about separating them into 2 slides or get rid of some of the unnecessary information. I hope you can have at least the results showing up. Yeah. So I think this is the end of the presentation slides. After that, you will prepare yourself to do an in-person presentation or record the videos like what I will show you on Canvas. The next step after the presentation would be to convert all this information into a report, which I show in the project modules. So you can look at how I've reformatted into a report format. You basically do not add any new things. You use the same slides, same screenshot, same data, and same output, but you formatted it so it become a document. Okay, so that's it. I hope you can work on your slide and do the presentation.